Today we shall study about cells in series and parallel combinations. As shown in the figure, two cells E1 and E2 are connected in series. Now we consider two cells in series where one terminal of the two cells is joined together, leaving the other terminal in either cell free. E1, E2 are the EMFs of the first two cells and R1, R2 their internal resistance. Let VA, VB, VC be the potential at point A, B and C. So, VA minus VB is the potential difference between the positive and negative terminal of the first cell. VAB बराबर VA minus VB बराबर V1 minus IR1. Similarly, VBC बराबर VB minus BC बराबर E1 minus E2 minus IR2. So the potential difference between the terminals A and C of the combination is VAC बराबर VA minus BC बराबर VA minus VB plus VB minus BC बराबर E1 plus E2 plus minus into R1 plus R2. So VAC बराबर E equivalent minus IR equivalent. Therefore E equivalent बराबर E1 plus E2 and R equivalent बराबर R1 plus R2. So the equivalent in EMF of series combination of n cells is joined is just the sum of their individual EMFs. The equivalent internal resistance of a series combination of n cells is just the sum of their internal resistance. Parallel connection. We consider a parallel combination of the cell. I1 and I2 are the currents leaving the positive electrodes of the cell. At the point V1, I1 and I2 flow where as the current I flows out. So I barabar I1 plus I2 as shown in the figure. Let VB1 and VB2 be the potential at B1 and B2. Then considering the first all the potential difference across its terminals is VB1 minus VB2. So V barabar VB1 minus VB2 barabar E1 minus I1 R1 for second cell V barabar VB1 minus VB2 barabar E2 minus IR2. इसलिए I बराबर I1 प्लस I2 बराबर E1 माइनस R बाई R1 E1 माइनस V बटा R1 प्लस E2 माइनस V2 बटा R2. बराबर E1 बटा R1 प्लस E2 बटा R2 प्लस माइनस V इंटू 1 बटा R1 प्लस 1 बाई R2. नाउ V बराबर E1 R2 प्लस E2 R1 बटा R1 प्लस R2 माइनस I R1 R2 बटा R1 प्लस R2. सो V बराबर E इक्विवेलेंट माइनस R इक्विवेलेंट. देयरफॉर E इक्विवेलेंट बराबर E1 R2 प्लस E2 R1 बटा R1 प्लस R2 and R equivalent बराबर R1 R2 बटा R1 plus R2. Therefore 1 बटा R equivalent बराबर 1 बटा R1 plus 1 by R2 and E equivalent बटा R equivalent बराबर E1 बटा R1 plus E2 बटा R2. Now the Kirchhoff's law. Electric circuit consists of a number of resistors and cells interconnected, sometimes in a complicated way. The formula we have derived earlier for series and parallel combination of resistors are not always sufficient to determine all the currents and potential differences in the circuit. The two rules called Kirchhoff's rule are very useful for analysis of electric circuits. Junction rule and loop rule. Junction rule: at any junction, the sum of the currents entering the junction is equal to the sum of the currents leaving the junction, as shown in the figure. Loop rule: the algebraic sum of all changes in a potential around any closed loop involving resistors and cells in the loop is 0. Now Wheatstone bridge. The bridge has four resistors R1, R2, R3 and R4 across one pair of diagonally opposite points A and C in the figure shown. A source is connected. This is called the battery arm. between the other two vertices B and D, a galvanometer G, which is a device to detect currents, is connected. This line shown as viewed in the figure is called the galvanometer arm. We apply Kirchhoff's rule to closed loop ADVA and CBDC. The first loop gives minus I1R1 minus I1R1 minus I1R1 plus I2R2 बराबर 0 at IG बराबर 0. Second loop using IB बराबर I1 I3 बराबर I1 I4 बराबर I2 I4 plus 0 minus I1 R3 बराबर 0. So I1 बटा R2 बराबर R2 बटा R1, इसलिए I1 बटा I2 बराबर R4 बटा R3. So R2 बटा R1 बराबर R4 बटा R3. This is the balance condition for galvanometer to give 0 or null deflection. So R4 बराबर R3 R2 बटा R1 called meter bridge. Now the meter bridge. The practical application of heat bridge is meter bridge as shown in the figure. The meter bridge is shown in figure. It consists of a wire of length 1 meter and of uniform cross-sectional area stretched out and clamped between two thick metallic strips bent at right angles. The metallic strip has the two gaps across which resistors can be connected. The end points where the wire is clamped are connected to a cell through a K. One end of a galvanometer is connected to the metallic strip midway between the two gaps. The other end of the galvanometer is connected to a jockey. The jockey is essentially a metallic rod whose one end has a knife edge which can slide over the wire to make electrical connection. R is an unknown resistance whose values we want to determine. It is connected across one of the gaps. The jockey is connected to some point D on the wire. A distance L centimeter from the end A, the jockey centimeter be moved along the wire. The portion AD of the wire has a resistance RCM, where RCM is resistance area, resistance of wire per unit centimeter. The DC of the wire has a resistance RCM 100 minus L. So for a balanced condition R bata S बराबर RCM L1 बटा RCM into 100 minus L1 बराबर L1 बटा 100 minus L1. The unknown resistance R is known in terms of a standard known resistance S by R बराबर S L1 बटा 100 minus L1.